Okay guys, the last subject we are covering is the influence lines for trusses. Influence line for a truss. We have the following truss. The question is, construct the influence line for any member. Calculate the force in any member due to a moving load at the bottom chord of the truss. The load will be moving from this location to this location to this location to this one, all the way to cross the bridge or to cross the truss. At each location, you are required to calculate the force in each member. In this question, for example, we are asked to calculate the influence line for member G, C, and GD. We can do the same for any other member. Good? Now, after you construct the influence line, the question is, if the moving load is 3 kN per meter, live load of 3 kN per meter, what is the maximum tension and compression that can be developed in the member? You draw the influence line, then you place the loading to maximize. You place the loading at the tension area to maximize the tension. You place the loading at the compression area only to maximize the compression. So let's draw the influence line for member GC. It's an easy one. Look, when you have the unit load here, nothing, no force in any member. So the force in member GC is 0. When you have the unit load here, look at this joint. This member is a 0 force member unless you have a load here. So at this location, the force in member GC is 0. 0. 0, 0. You connect with a straight line. Between the joints, you connect with a straight line, not mustaqim. Then when you have the unit load moved to here, this will be 1 positive tension. So this is 1. When you connect straight line, then when you move here, 0. 0. You connect straight line. Then 0 here, straight line. So this is the influence line. Only when you have loading here and here, this member can have force. بس يكون اللودing هون وهون. Otherwise, if the loading is here or here, no force in this member. So you can ask me a question. ما بصير يكون عندنا loading here. We cannot have loading here, right? For a truss, we say the loading must be at the joint. How we can have loading here? The loading is on the bridge deck. There's a slab, there's a slab here. The cars are on the slab. The slab is supported with beams. This is your slab. There's a beam here, there's a beam here, there's a beam here, a beam here, a beam here. This beam is carrying the load on the slab and supported by the truss here. The load جاي من الbeams only at the joints. There is load here in between, on the slab, not on the truss. The load comes. Now this one will have, if you have a load in here, this will have a reaction, this will have a reaction. So you have a force in this number. This is the case here. This is the case here. ما في loading on. You can't have loading on the truss directly. This loading is on the slab, transferred to the beams. Then the beams are transferring the load to the joints. Good? Now, what's the maximum tension or compression? C max, the compression, C max equal 0. No compression area. 0. All the area is tension. T max is the intensity of the distributed load times the area. 3 times half times 6 times 1. 9 kilo Newton. So this member must be designed as a tension member to carry 9 kilonewton meter. Good? Easy one. This one is easy. You should know how to analyze a truss in order to do this. You should تعلم كيف يسمى truss. Each location you are analyzing a truss. At each point you are analyzing the truss. Now the second member is this member. GD. The easiest section to do for this one is to take the moment we continue the slope of this member, if we continue the slope of this member GF all the way, good. What's this angle here? This angle, tan inverse of 1.5 over 3 equal this angle, tan inverse of 1.5 over 3. 26.5 or 16? 0.6. Okay, now look, this angle, is it equal to this angle?
Yes.
So this is 26.6. Good? If this is 26.6, we need this distance. We need this distance. Sine 26.6 equal 3, sorry, tan 26.6 equal 3 over this. So x, this distance x equal 3 over tan 26.6 equal 6 meters. All of it is 6. So this is 3. 3 and 3. Good? 3 and 3. I'll show you why. Now all this is for the analysis. Now look, this is our section will be. When we take the section, we will have this force in this member. Force in this member, let's assume a tension when we take the cut. And a force in this member. Assume tension. When I take the moment at this point O, this force gives you 0 moment. The same line of action. This member gives you 0 moment. Only this member will give you a moment. And the reaction here. What's this angle? Tan inverse of 4.5 over 3. So this angle is tan inverse of 4.5 over 3. 56.3 degrees. So we have everything. Now the horizontal component of this force is what we want, GD. Cosine will give you 0 moment here. The sine will be multiplied by 6. Good? So, when we have the unit load here, so all what we need to do is find the reaction. When we have the unit load here, 1. How much is this distance? 3. 3. If the one is here, what's the reaction here and what's the reaction here? 1 quarter, 3 quarter. Now look, if you have it in the middle, 1 is in the middle. Half. If you have it here, 3 quarter, 1 quarter. If you have it here, 3 quarter, 1 quarter. يعني الواحد يقول لك مثلا كيف؟ يعني take the momentary equal to 0. 1 times 3 equal the reaction times 12. So it's 3 over 12 quarter. So first equation, what's this one? Quarter. Now take the moment at E, at O. Equals 0, counter, positive. We have. What do we have? Okay, let's take care of this one. Minus 1, 4 times 3. Now this force, the sign of the angle is also clockwise. So minus GD sine 56.3 6 equals 0. You do this, you get GD equal minus what? Minus 0.15. It's minus. See the Mahmoud? Minus 0.15. Connect straight line. طلع السؤال. If we have it here, how much the reaction? نص. شو بيتغير? What will change? Twice. The only thing will change here, this will become half. It means twice. It means the result is 0.3. بيتغير قيمته بس. Your equation, this is the only thing will change. It become half. Good. You have to go. There is a trend. So this is will go to 0.3. I will continue this slope. Good. Now, when we have it here, this will become 3/4. يعني نضرب 3. يصير 145. Wrong. غلط. Now, if the unit load is here, this will affect in the moment. If the unit load is here, this one is 3/4. But look at the moment equation. Would be 3/4 negative that plus 1 times 6. Plus again 1 times 6 counter. 1 times 6 equal to 0. This will give you GD equal 175 tension. Check it. 175 tension. You connect straight line. Then you know it's 0 here. That's it. That's the influence line for the force and member GD. The influence line due to one moving load. The question is calculate the maximum tension and the maximum compression due to 3 kN per meter moving distributed. Now, for the maximum tension, where we place the load for the maximum tension? On this area only. And the load will be here. Only on the tension. For the maximum tension. For the maximum compression, on this one only. So we need this distance, right? X. From similar triangle, x over 0.3 equal 3 minus x over 0.75. You have x equal how much? 0.857. Good? 0.857. So this is 0.857. And this one from here to here, 3 minus this one, 2.14. Now, let's do it here. T max. T maximum tension equal half area times all of this. 5 times maximum ordinate of the height is 0.75 times the intensity 3. 5.78. That's it. kilonewton. That's maximum tension. C max half times 6 plus this times 0.3 times 3. 3. Approximately 3. Okay. So this member must be designed twice. So number 10. As a tension member for 5.78 and as a compression member for 3.12. Yani sometimes this one will control the design. Even this one is lower. Sometimes the compression control the design. Why? Because compression members we need to worry about, and when we design, we worry about strength, يعني التحمل. In compression, we have compression member, we worry about buckling. Buckling. يعني this member, if we apply tension, how it will fail? If you break it. So it's the strength. If you apply compression, this is failure. Buckling means failure. Before you break it. See? So there is Euler buckling. Euler buckling. No, you have to design it. You have to design the member. Remember, there is a slenderness limit. You know what slenderness ratio? محمود وضح لي هاي هون. slenderness مش مطلوب منك ratio. What is it? أنا سامع فيها. K L over R. This is called slenderness ratio. K is a factor reflecting the end condition. Factor, constant for the end condition. If we have pin, K equal 1. Actually it's for the effective length. يعني KL is the effective length. The distance between the two inflection points. Give me المسطرة. Mahmoud. So we have this one, pure pin. Okay? See the inflection point at the top and at the bottom. So the full length, كل الطول is effective. So KL equal 1. KL equal L. So K equal 1. If you have fixed, it will be half. See the effective length become here. If it's fixed. Fixed free, يعني there is a factor given. If it's pin, 1. There's different cases. Good. This is the length. R, radius of gyration. Radius of gyration. Now, the critical load, how much load I apply to buckle the member, is provided by Euler. Euler. P critical equal what? Pi square E R over K L square. Are you following? KL square. يعني this thing should be covered in strength. لازم تحطوها بالstrength. You should have coverage. أنا عارف ما تحطوهاش. لازم أحطوها بالstrength. This is Euler. This is the moment of inertia. Elastic modulus. This is pi 3.14. 22/7. This is K. Fact. L is the length. This is Euler, the critical buckling load. How much load I can apply to cause buckling? It depends on the length of the member, it depends on the area, which is I, it depends on what material, steel, metal, wood. Buckling is failure. Good? Now look. Is there a relationship between I and R? Radius of gyration equal what? I over A. So R square equal what? So I equal what?
R square B.
So that's I, right? That's I. This is A R square. طلع. نزلنا جوا. Euler كان يعني إذا شفت المكان ثاني ما تفكر لي غلط. This is a different version of Euler. Pi square EA over KL over R عشان slenderness. KL over R square. This is the same as I without the R. Or substitute A R. If you are asked to calculate the critical stress, is the critical force over area. So this is the critical Euler stress. Pi square E على A through this is the end of the course.